Now let us see differential equations which are reducible to homogeneous form. So here let's consider dy by dx given by a1x plus b1y plus c1 upon a2x plus b2y plus c2. So in short, we are given a differential equation which is of the form dy by dx given as the ratio of two linear expressions in x and y. Okay. Now here if we see, the given equation is not a homogeneous equation because the degrees of all the terms are not same. So this can be converted into homogeneous form by suitable shift of origin. So therefore we must replace x with capital X plus h and y with capital Y plus k. So on doing that, we will get a new equation in which we will have d capital Y upon d capital X given by the expression as shown here. Now if you observe, we will see the first section, that is a1 capital X plus b1 capital Y upon a2 capital X plus b2 capital Y. If we think of only this particular portion, then this is a homogeneous expression, correct? But if that is the case, then it means that whatever are the remaining terms which are shown in yellow color here, they must be 0, isn't it? Because only when they are 0, the remaining expression is a homogeneous expression. So that means if we choose the values of h and k intelligently so that the yellow colored terms vanish, that is if they become 0, then we have effectively got a homogeneous differential equation. So therefore, by equating the last two portions of numerator and denominator on right hand side, that is a1h plus b1k plus c1 equal to 0 and a2h plus b2k plus c2 equal to 0, we can solve these two simultaneously to get the values of h and k, right? So now we solve the homogeneous differential equation using the procedure that we have already seen, and at the end we substitute the values of h and k to get the solution in the original variables, which are x and y in lowercase, right? So let us see one example so that this process will be clear. Now here we are given dy by dx equal to x minus 2y minus 1 upon 2x plus y plus 8. So currently it's not in homogeneous form, but to convert it we have to do the shift of origin. So therefore let us put small x is equal to capital X plus h and small y is equal to capital Y plus k. So basically h comma k is our new origin. Now by doing this, we will get dy by dx as nothing but dy by dx in uppercase, because simply because h and k will have derivative at 0. So therefore there won't be any change in the way the derivative on left hand side looks like. Okay. So that is the first part. So therefore we have dy by dx is equal to small x we replace with capital X plus h minus 2 into y we write as capital Y plus k minus 1 as it is upon 2 into capital X plus h plus y plus k plus 8. Right? So now collecting the terms, we have x minus 2y. Right? We purposefully collect the first degree terms. So therefore remaining we have h minus 2k minus 1 in the numerator whole divided by 2x plus y plus 2h plus k plus 8. So now if you observe, the first portion is a homogeneous expression. So in order to get that, the remaining two parts must vanish. So therefore we must equate them with 0 and solve for h and k. So this implies if we want the homogeneous form, then we must have h minus 2k equal to 1, taking 1 on the other side, and 2h plus k must be equal to minus 8. Now simple way to do this is, let us multiply the first equation by 2 so that we can later on subtract. So 2h minus 4k is equal to 2, and now let us use the subtraction here, that is second minus third. So 2h will get cancelled, k minus 4k is 5k is equal to minus 8 minus 2 is minus 10. So that gives us k equal to minus 2, and putting that in any one of the equations we get h to be equal to minus 3. So here we have got what should be the values of h and k so that the resulting expression becomes homogeneous. So therefore, considering that homogeneous equation, now we have dy by dx equal to x minus 2y upon 2x plus y. The remaining portion would have vanished by putting h as minus 3 and k as minus 2. Now the equation that we have in front of us is a homogeneous equation. So for that, as we are already aware, we have to put y as vx in uppercase. So therefore we have dy by dx as nothing but v plus x dv by dx. Alright, so therefore we get v plus x dv by dx is equal to x minus 2, in place of y we write vx whole upon 2x plus vx. So therefore on cancelling we will get 1 minus 2v upon 2 plus v, and we already have one v term here. So on cancelling that v term, let us subtract it on right hand side, so that on left hand side we would have got only x dv by dx, right? So this in turn gives us, by cross multiplying and clubbing, we have 1 minus 2v minus 2v minus v square whole upon 2 plus v. So that in turn gives us minus v square minus 4v plus 1 upon, we may write say v plus 2. So that is x dv by dx. Now this becomes a variable separable. Now let's bring all the v terms on left hand side and x terms on right hand side. Now for the sake of simplicity, let us keep the minus sign on the right hand side only while bringing the v terms on left hand side. So we have v plus 2 divided by v square plus 4v minus 1 times dv is equal to minus 1 upon x dx. Right? Now to solve this, we have to integrate both sides. Now how do we solve this particular equation? If you observe on left hand side, we have linear upon quadratic form. Now let's see what's the derivative of the denominator. So that is nothing but 2v plus 4. And now we closely observe that the numerator, if we multiply by 2, we will get exactly the derivative of denominator as we want. So that means we have to just adjust the factor of 2 so that we get the derivative of denominator in the numerator. Right? So therefore we write it as 1 upon 2 into 2v plus 4 upon v square plus 4v minus 1 times dv is equal to minus 1 upon x dx plus c we will write after we do the integration. So therefore here we have 1 upon 2 log of mod of v square plus 4v minus 1 is equal to minus log x plus log c. So if you want, we can consider half as the power of this particular expression and then remove the log. So therefore on doing that we will get square root of v square plus 4v minus 1 is equal to c upon x. So now let us bring x on left hand side and then simplify. So therefore we will get x into, now in place of v we must put y by x, so that gives us y square by x square plus 4y by x minus 1 is equal to some constant c. Now if we take the x inside the square root, we will be left with y square plus 4xy minus x square is equal to c. Now if you want, we can even square both sides. So we will get y square plus 4xy minus x square is equal to, now c square can be termed as yet another constant, say c1, right? And at the end now we must replace with the original variables. So if you observe, small y was equal to capital Y plus k. So capital Y is nothing but small y minus k, and k is minus 2. So therefore capital Y is ultimately equal to y plus 2 the whole square plus 4 into, now same for x, we will have capital X as small x plus 3 into y is once again small y plus 2, and the last term is minus x square, so that is minus x plus 3 the whole square is equal to c1, right? So that's the constant. So basically that is the final answer to the given differential equation.